Okay, I want to welcome you back to biology. I'd like to welcome our viewers at home back to biology. Yesterday's recording was made entirely in the dark, and it still came out. But I want to add on a few vocabulary words for experimental design that we didn't talk about specifically. And so, let's see. We can start with what does a controlled experiment mean? Let's change from flower height, and let's say that I wanted to talk about whether or not Monster drinks make you run faster. Right? We haven't had that discussion in here, have we?
No.
Okay, good. Just curious, who thinks a Monster makes you run faster? Energy drink. Just curious. Yeah. I don't really know. I know that some research has been done, and it shows that most of those kind of things don't have much of an effect. But if you wanted to test it, you could do an experiment, right? And, you know, probably what you would do is you would get a group of people. First of all, why do you want a group of people and not just one person? To say that.
It's different for each person.
Right, people are slightly different, and so if you take a large group of people, ideally more than 100, but definitely more than 10 is the rule of thumb. Has to be more than 10, should be more than 100, but to get good results. But anyway, you take a group of people, and you give that group Monster, and you send them out on the track to run, right? Good experiment? People are thinking, I probably mean no, because I just set you up, right? You know, you're sensing a setup. No, not a good experiment. Why not?
Wait, what was the experiment?
So if I just said, you take 100 people and you give them all Monster drinks and you tell them to run out onto the track, yeah?
Because you don't know how fast they run without the Monster.
That's right. You don't know how fast they run without the Monster. That's exactly right. You need to. That's why they call it a controlled experiment, because you want to have a control. You need a control group. And you need an experimental group. All right? And so the control group is the one where you don't change anything. So the experimental group, they're the ones that are going to get they get some sort of variable changed. But for comparison, oh my God.
What?
I'm writing wrong things. Comparison. For comparison, one group is left unchanged. And I'm going to write IE, which means in example, IE, for the purposes of our Monster, does it help you run faster? I.e., the control group would get water instead of Monster. Why water and why not just nothing? Just curious.
Because we need water to sweat and produce energy.
Well, there is that, but as far as the experiment goes, what were you going to say?
Lubrication.
Great muscles.
Joints.
Lube.
Well, yeah, right. But I mean, the point is, why water? Because there's water in the drink. So the people drinking Monster are drinking something, and so if you just gave some people Monster and other people nothing, then you might, and you got results. Then you could say, well, maybe the results are just because the other people didn't drink anything at all, and they didn't have any water. They didn't have any. So if you give one group water, a liquid with theoretically no effect, except for all the things you guys just said, and then another group Monster, then that's different. Then you're changing one thing.
Sure.
That's the whole thing. So the experimental group, I'm going to do this in a different color because they're so close to each other. Experimental group, I'll do a red line here. You're going to change one variable. Usually. You're going to change one thing, not like 5 things. So you have to, what you have to do is you're really testing everything else ideally staying the same. Like the 2 flower seeds grown in one place so you can compare how they grow, or monster versus water. You're changing one variable. See, if you just gave it monster versus nothing, again, that's 2 things. You have one group drinking a liquid and drinking all that energy stuff, and you have one group drinking no liquid with no energy stuff. That's 2 variables. Like, and also, by the same token, you wouldn't want to make one group drink monster and the other group, or like you have one group not drink monster and then one group drinks monster and wears a sweatsuit and has weights on their ankles and has birds pecking at them while they run, or or whatever. Because then you're testing more than one thing, and when you get results, you can't say, well, that was, we definitely see a result that tells us about the monster, right? So you only want to change one thing. And your experimental group is the group that gets the different thing. Like yesterday, the experimental group was the flowers that were moved from 2,000 meters down to 1,000 meters. The control group was the 1,000-meter plants that were grown at 1,000 meters, right? Because nothing changed. They're left the same. They're left alone. So otherwise, you have nothing to compare to. Okay, so there's that. I'm trying to think. You see, I talked about this a couple days ago in the other class. I'm trying to remember the other stuff that I said so that we're all sort of on the same page here. Let me just stand here and think for a second. I'll edit this out so I look smarter. Oh my God. Can you wait just a few minutes until I get done with this part? Can you wait like 3 minutes?
I believe so.
Excellent. Mr. Redmond, do you remember anything else that I mentioned this? I know I mentioned other stuff. Oh, well, there was the dependent and the independent variable. Okay, so when you look at your data, like I would make a graph, right? I would have my control group, and I would have my experimental group. They would drink probably the same, what you doing? They would drink the same amount, right? Also, you wouldn't have one group drink 500 milliliters and the other group drink 100 milliliters, right? They drink the same amount. They would run the same distance, let's say 50 yards or 100 yards or around the track once or a mile, whatever it was that you decided you were going to test. Everybody would do the same thing. And so then I would graph my data, right? Your data is the information that you get from your experiment. And so let's say I'm going to have a graph and I need to have my 2 axes to compare it to so I can plot my data. And I have what? What are the 2 things I'm going to have on my graph?
Like
Time. What's the other thing going to be?
distance.
No, because everybody's going to have the same distance. So
Monster.
right, monster or water. Right, exactly. So, and the thing is, the question is, well, where do I put them? The thing that is constant, in other words, that determines the rest of it, is going to be down here. It's really just going to be monster or water. This is called the independent variable.
Are we supposed to draw that?
Yes. Independent. A-N-T or E-N-T? Spelling.
E-N-T.
E-N-T, thank you. Independent variable. In other words, it's either this or this, and it'll make more sense when I tell you what we call this other one up here. The other one, as you guys said, is going to be speed or time, probably. Right? Time, let's say time to run 50 yards. Time to run 50 yards. And let's say 50-yard time is about 5 seconds, let's say on average. So maybe I'll do 1, 2, 3, 4, 5, 6 seconds. Okay, this, and after I say this last thing, I'm going to give you guys a couple minutes to make sure you write it all down. This one is called the dependent variable. Okay, the dependent variable, because it is going to depend on which of these you have, right? So this is independent because I either give you one or I give you the other one. But the dependent variable depends on which of these. So the value you get for this is going to depend on which of these you get. And so now I'm going to make up some data. Okay, while you guys go ahead and make sure you get all that down. I want you to have, when I look at your notebooks, which I do for notes, did I tell this class that already? Yeah? Okay. This is what I'll be looking for. A nice complete version of this. And yes, you may now go.
I finished all that.
Okay, yeah, now you can go. And you can get the data off of this when you come back, okay? But basically, I'm just making the data up anyway.
Okay. I'm not right where I'm going. I'm just gonna.
If they'll let you in there without a pass, that's fine. Or I mean, why don't you fill out a pass anyway?
I was talking about the sign up.
Yeah, don't worry about that. I start using that if I have a problem with people wandering. Like if I start getting the feeling that people are going to the bathroom and then wandering around the school, then I start asking people to sign in and out.
No, it's just really hard for me to write.
Yeah, I understand that. I should have filled that out for you. Actually, that would have been nice of me, wouldn't it?
Sorry, I like this.
Remember, said that
What's
was
the
nice.
date?
13th of September,
Days.
2012. Anno Domini.
Hopefully I don't crash on the
Overkill.
That's how I roll. Either overkill or underkill.
Yeah.
Either overkill or half baked. Okay, so let's say I'm going to just go like this, and I'm going to prove my own point. All right, and so anyway, that would be my data. So again, the independent variable is either this one or this one, but the speed, if you really do have prove something in your experiment, the speed is going to depend on which of these you had. So which of these is better? Don't forget, smaller is better when it comes to running. You want to run faster. So having a bigger number here doesn't make you the winner. If you don't know that, you probably shouldn't go out for the track team. Or play golf, for that matter. But so those are two things where a lower number is better. Unlike football, soccer, basketball, where a higher number is better. But okay, or bowling. But so this my data here says that you run the 50 in 5.5 seconds when you're drinking Monster, and 3.5 seconds when you're drinking water. And so that sort of goes to prove my point, I guess. I don't think there's anything else on. Yes? I think so. Is there anything else that you think I forgot? That you remember from the other time? I don't think so either. Okay, yeah, that's fine.
What's the magic number today?
What's that?
What's going to be the magic number?
The magic number today is 3.5. Okay, thank you very much.
Like our eyes just as it comes in.
So remember 3 and 3.5.